Did you know that the LPG cylinder you use in your home every single day actually begins its journey deep underground as crude oil buried beneath the Earth's surface? Think about that for a moment. What looks like a simple gas cylinder in your kitchen is actually the final result of a journey that started millions of years ago. A journey where ancient organic matter, transformed under extreme heat and pressure over time, becomes a powerful source of energy. This is not a simple or quick process. It is a long, complex chain of events where nature and modern technology work together. Deep beneath the earth, crude oil exists in a raw, unrefined state. It is thick, dark, almost black in color, and filled with a mixture of many different hydrocarbons and chemicals. In this natural form, it is not useful for direct consumption. It cannot be used as fuel just like that. So the question is, how does this heavy, unusable liquid turn into the clean, efficient gas you use every day? The answer begins when this crude oil is extracted and transported to a refinery, because that's where the real transformation starts. A refinery is not just a factory. It is a highly advanced system where science and engineering come together in perfect coordination. Every pipe, every chamber, every temperature setting is carefully controlled. Nothing here is random. Every step has a purpose: to separate crude oil into its different components and convert them into useful fuels like petrol, diesel, jet fuel, and LPG. What looks like a single substance is actually a complex mixture, and the job of the refinery is to carefully break it down piece by piece. The first major step in this process is heating the crude oil. But this is not ordinary heating. The oil is heated to extremely high temperatures, so high that it begins to boil and turn into vapor. Now here's where an important scientific principle comes into play. Every substance has its own boiling point. This means that as the temperature rises, different components of crude oil begin to evaporate at different times. Some turn into vapor earlier, while others require more heat. This hot mixture of liquid and vapor is then sent into a massive vertical structure known as a distillation column. This column is often considered the heart of the refinery, and inside it, one of the most fascinating separation processes takes place. As the vapor rises inside the column, it begins to cool down gradually. Heavier components, which require higher temperatures to stay in vapor form, condense earlier and settle in the lower sections. Lighter components continue to rise higher before condensing. This creates a natural separation, layer by layer, based entirely on boiling points. At different heights of the column, different products are collected. Near the bottom, you find heavier products like fuel oils. In the middle, you get diesel and kerosene. And at the very top, the lightest gases are collected. From a single raw material, multiple valuable fuels are created. And among these, the gases collected at the top are the most important for producing LPG. But these gases are not ready yet. They cannot be used directly. They go through further refining processes where specific gases are separated out, mainly propane and butane. These two gases are the primary components of LPG. However, there is a challenge. These gases are extremely light and highly volatile. They mix easily with air, and if not handled properly, they can be dangerous. That is why refineries use specialized purification systems. These systems remove impurities such as sulfur compounds, moisture, and other unwanted substances. What you get after this stage is clean, high-quality LPG, but still in gaseous form. Now comes a crucial transformation. Gases are difficult to store and transport because they expand and take up a lot of space. So, how do you fit so much gas inside a small cylinder? The answer lies in pressure. When LPG gas is subjected to high pressure, it changes its state from gas to liquid. This transformation allows a large volume of gas to be compressed into a much smaller space. That is why LPG cylinders can store so much energy in a compact form. Inside the cylinder, LPG exists mostly as a liquid, with a small portion remaining as gas at the top. Once liquefied, LPG is stored in large, secure tanks at the refinery. Safety is extremely important at this stage. LPG is highly flammable, and even a small leak can be dangerous. Strict monitoring systems are used to ensure everything remains under control. Next comes the cylinder filling process. Empty cylinders are first inspected carefully. They are checked for leaks, structural damage, rust, or any defects that could make them unsafe. Only after passing these checks are they sent for filling. Automated machines then fill each cylinder with a precise amount of LPG. This process is highly accurate. Even small variations in weight are detected and corrected. After filling, the cylinders are sealed tightly to prevent any leakage. These sealed cylinders are then transported by trucks and distributed across cities, towns, and villages, eventually reaching homes like yours. A long journey ending right in your kitchen. But here's an interesting question. If LPG is so dangerous, how do we detect a leak? Does LPG have a natural smell? The surprising answer is no. Pure LPG is completely odorless. It has no smell at all. So the strong smell you notice is not natural. A special chemical, known as an odorant, is added to LPG during the refining process. This chemical has a strong, distinctive smell. Its only purpose is safety. If there is ever a gas leak, this smell immediately alerts people, giving them time to react and prevent accidents. Imagine how dangerous it would be if LPG had no smell. Leaks could go unnoticed, and the consequences could be catastrophic. This small addition plays a huge role in saving lives. Now, when the LPG cylinder reaches your home, its final phase begins: usage. When you turn the stove knob, something interesting happens inside the cylinder. The liquid LPG inside the cylinder experiences a drop in pressure, and instantly it starts converting back into gas. This gas flows through the pipe, reaches the burner, and ignites, producing a steady flame. So inside a single cylinder, a continuous cycle is taking place. Liquid turning into gas, gas turning into energy, all happening smoothly, silently, and instantly. This is one of the reasons why LPG is so widely used. It burns cleanly, produces very little smoke, heats quickly, and is highly efficient for cooking. That's why millions of households around the world rely on it every day. So the next time you see an LPG cylinder in your home, don't think of it as just a simple container. Think of the incredible journey behind it. From crude oil buried deep underground, to complex refinery processes, to advanced separation systems, to safe storage and transportation, and finally, to your kitchen. It is not just fuel. It is a masterpiece of modern science and engineering. A perfect example of how human innovation transforms natural resources into something incredibly useful. And perhaps the most fascinating part is this: we use it every single day, yet we rarely stop to think about the extraordinary journey behind it. Thank you for joining me on Metrixor. I'll see you again in the next video.